All right, so this is the second part, or second video for distance formula. In the last video, we looked at the Pythagorean theorem as one way to find the distance from this point to this point. Okay, so we determined that this length was 7, this one was 4. We made a right triangle out of this, and then we used the Pythagorean theorem, which is a squared plus b squared equals c squared. Okay, ran that out, and we were able to find that distance c. Okay, so what I've done here is I have rewritten the Pythagorean theorem to put the c squared on the left. Everything else is the same. We just switched from left to right, right to left. Okay, because I'm going to derive the distance formula, which is going to allow us to just, all we need is these coordinates, and we'll plug them in, and we can plug them into this formula, and we'll be able to find this distance without having to drop a right triangle and do all this stuff. Okay, so in the last video, we determined that this length here, was just the distance on the x-axis from this point to this point. And we determined that the x was 2 here, and it was 9 here. So if we do x2 minus x1, we would get 9 minus 2, and then we got that quantity squared. Okay, and then b squared is just this distance here vertically from the y point here to the y point here. Well, the y here is 1 and the y here is 5. And if we look at our coordinate, right, the y2 is at 5, the y1 is at 1. So we would just plug those in. 5 minus 1 quantity squared. Okay, so now to solve for c, we would just simplify this. And so we got, like we did before, we had 9 minus 2, which was 7, squared plus 4 squared equals c squared. So I was writing a little tiny there, but it doesn't really matter because this is just kind of showing us if we ran this out, we would take the square root of both sides, and then we would have our solution. Okay, well, I'm going to erase this because we're not going to do it this way. We're going to derive the formula, and then we'll do it that way, and we'll show you that we're going to get the same answer. Remember, our answer before was square root of 65. Okay, so to derive this formula from right here, before we even plug in any stuff, if we took the square root of both sides, okay, so the square root of a square, we just end up with c. Well, instead of c, we're going to call this d because it's a distance. So we're going to replace this c with the letter d. And then the square root of x2 minus x1 squared plus y2 minus y1 squared. And this is the distance formula. Okay, so this is the formula that you're going to want to write down in your notes. You're going to want to write down on your paper when you do this assignment. Okay, so then we would just plug in our information just like we did over here. So then d equals the square root of 9 minus 2 squared plus 5 minus 1 squared. That's the stuff we had before, right? 9 was x2, 2 was x1, okay? 5 was y2, 1 was y1. Okay, and that equals the square root of 9 minus 2 is 7 squared plus 4 squared equals the square root of 49 plus 16, which is what we got before, equals the square root of 65. And just like in the last video, we punch that into our calculator, we get 8.07 or whatever it was. But that's how we get the distance formula. So now, when you have this formula, this is the distance formula. So I want you to write that down. D equals the square root of all this stuff. And we can just plug in our coordinates and run out the equation.